Welcome to the 66th video in our series about Unix tools. Most real C programs have more than one source file. There will be only one file with the main function, and it will include local headers to gain access to the subroutine prototypes of the other files. The fancy computer science name for this technique is separate compilation, and GCC supports it. I've rewritten our one file C program to use two files. The file with main is called myprog2.c, and the file with the talk to me procedure is called mysubs.c, and mysubs.h is the name of the header file with the prototype for the talk to me procedure. If you don't understand terms like prototype, subroutine, procedure, function, you need to go back to your C programming material, and if it's good, it will tell you all that. I've shown you right here, and you can read how to build this application by hand with no IDE, no build tool. So let's stop goofing around. Let's do it. First, I should show you the files. So here's myprog version 2, and you can see it doesn't have the talk to me. It uses it. It has a call right here to talk to me. But it can do that because it gets the prototype from mysubs.h. And so if we look at mysubs.h, you'll see it's got the prototype, it's got the header guards. If you don't understand header guards, go back to that C programming book. Okay, and then mysubs.c has the actual talk to me code for that procedure. Okay, so myprogs2.c, and I've got mysubs.ch. Those are the myprog2. There we go. Those are the files that we want to turn into our application. So the first thing to do is to create an object file for the subs. So you don't ever mention the header file here. You just mention the C file, and the C preprocessor will get the header for you. So we say compile mysubs.c into mysubs.o. And then I also need the myprog2 because that has the main. So I say GCC, again, compile only myprog2.c into myprog2.o. Now I have the two object files that have the machine code, but we don't have any way for that code to run yet because we have to do the link, and the link will connect these two object files, and it will also connect up printf from the C standard library. And we do that by GCC and then myprog2.o and then mysubs.o, and then we say output all that into myprog2, and it's done. And then to run it, don't forget you need to put a // in front and then say the name that you gave right here, myprog2. And it runs, it shows the 5 lines. It does the same thing as our original program from the previous video, but we've used separate compilation to achieve this. And if we take a look, at the recent files, if you look at the dates here, you could see I've put with ls-lartd, I've put the newest files last in the list, and then I've sent that through the pipe, and then I said show me the last 10 lines. We only need these three. These three are the new files we just created. We created mysubs.o, which has the talk to me function inside. We created myprog 2.0, which has our main inside. And then those two object files were linked together with the C standard library to create the myprog 2 application. Wonderful. We can do separate compilation. I think you can understand if we had 3 files or 100 files, you'd have a "-c" compile for every single C file. And then the last thing you would do is the link, which didn't use the "-c". If you're compiling things by hand, this is how you do it. And this allows you to do the separate compilation. After your final program has been linked, we don't need the .o files right now anymore. But we're going to leave them on the disk, and I'm going to show you why. Why would you use separate compilation? It looks more complex. It takes more steps. So why do people do it? Well, let's modify the mysubs, which has the talk to me function inside, and let's change it and say we want to do it n times, and we're going to send the n in. We're going to make n be an argument, and then we're going to say I can do it n times, right? And you say, wait a minute, I'd have to change my main. Undo that and just change it to 10. Okay, that's simpler. So this is going to do it from 0 through 9, which is 10 times. Okay, let's take a look at our files again, and we see, aha, mysubs2 is newer than mysubs0. I need to remake mysubs0. So I'll do the compile of mysubs.c, and I'll output mysubs.o. And then I'll look at the files again, and I'll say, okay, mysubs.o came out later than this, so it's newer. What about myprog 2.0? Well, that is older than this. You have to make sure every .o is newer than every .c. And after we've done that, you can see I don't need to make a new myprog 2.0. It's already newer than this, so I can skip that step, and I can just do the link. I'm going to recycle the old myprog 2.0. I didn't have to compile it again because I didn't change anything in myprog 2.c, but I did make a new mysubs.o. And then if I say myprog 2 and I run it again, we should get 10 lines of output. But with 10 lines of output, it gets tricky to count, so you can run it through the word counter, but we're going to say count lines with the -L, and you see, yes, we got 10 lines of output. So our program is doing what we want it to do, and you can see we saved time. Let's go back and look at the history. The first time, I had to compile both things and do the link. Okay, that's the first time. But the second time, I only had to compile the C file that changed, and then I redo the link. These numbers on the left are to tell you a shortcut to rerun some command in the shell. Don't worry about them. Okay. Quick review. Separate compilation is easy. If you follow the C programming rules, you know that you'll have a main program. In ours, it was called myprog2.c. It has no header. But every other .c program will need to have a .h with the function prototypes and any global variables they use. If you're building the application after the first time, so the second time, the third time, the fourth time, You only need to do the GCC minus C to recreate object files if you change the C file. If you didn't change the C file, you don't need to make a new object file. You can recycle the old object file because nothing changed. And the final step is always the same. You need to do the link of all your object files to create the executable. Okay. I still know you want to find some better way to do this, but I have to show you step by step so you understand what we're doing. And today, the thing you needed to realize was, before I do my link, I check, is my .o newer than my .c? And with this kind of time display, you might not be able to tell. But remember, we had the stat command. And if we look at the stat command output, we can see the last modify time for the .c file is here, and the last modify for the .o is here, and it's greater. It's 28 seconds, and this one's only 7 seconds. So the .o is newer. I don't need to rebuild it. And if I did the same thing for myprog2, we can look at those times again, and we say 11:42:59, 11:31. Okay, that's already greater. I don't need to rebuild the .o files. I just have to link it. Okay, come back next time, and I will show you how to automate this so you don't have to type all these long command lines. Until then, thank you for listening.